Just a second. The thing that, guys, good morning, Arya.
Morning, teacher.
How are you?
Good.
Awesome, glad to hear it. It's a beautiful day, guys, huh?
Yes.
It's rainy, it's so beautiful. And it makes a perfect day for the second part of the trigonometric equations, isn't that? Especially with the prospect that you're gonna have a very long weekend, Saturday, Sunday, oh my God, Monday, I can't wait for it.
Happy
Lots
Friday.
of sleeping, guys, huh? Okay. Now, guys, the thing that we have planned for today is that we are going to do the second day for the trigonometric equations. But for this day, we plan to do some different things. And the thing is that we just want to cover some trigonometric, I should say, identities in order to solve a trigonometric functions, that equations that we talked about these identities a couple of weeks ago. But before that, in order to just help you wake up fully and catch up with the things that we learned yesterday, I'm just going to give you this exercise that you please take a couple of seconds to look at it, then we solve it together, then we just have a review on the things which we learned yesterday, we move on to the new topics then. This is going to be this. We call this function, oh, let me change the light. I think it's going to be too much. Okay, let me put this one here. Good morning, David. Okay, we said that this equation, that it's going to be 3 times cosine squared of the x plus cosine of the x minus 2, it equals to 0. Okay, and now we have this equation. I just want to please spend a couple of seconds to check the notes which you made yesterday to see how can you just proceed with this. In after a couple of minutes, I join myself to solve that together. We finish it together. Everyone sees what I have written? Inge, Oliver,
Yes.
Ariane, Arya, everyone sees it?
Yeah.
I'm so glad to hear it. This is 3 cosine squared of the x plus cosine of the x minus 2 equals to 0.
Minus 2.
That's right.
Okay.
And we're looking, I should say, for all the solutions, not just the solutions within one full unit circles. We're looking for all the solutions. Then you need to just incorporate the periodicity of the cosine functions into your final answer. Okay. Okay, in the meantime, that guys you're working on your stuff, I'm gonna write this one that Mingji is gonna be for presenting for next Friday. Oliver presenting on Wednesday. And Brian is gonna tell me later what date he's gonna pick up. I'm gonna talk to Linda about the project later. David is gonna tell me what date he's gonna picking up for his project. And Arya, did you present your radioactive decay in cancer therapy?
We plan to present it next Tuesday.
Next Tuesday. Oh, yeah, you're right.
Yes.
Arya was next Tuesday. And also, then it remains with Brian and David to tell me by the second half of the class which date you pick up. And also Oliver for the COVID-19 challenge. I'm going to provide the resources for you today before 8 p.m. Then you said that you're going to do that anytime before May 27th. Okay. It's going to be for Oliver then. And also Brian and Dark Knight and David, they're going to get back to me soon to tell me what date they prefer to talk about the project. Okay, guys, let's, if anyone is done now for this exercise? No one? You don't mind if you just work together and finish it together? Great, look at this one. This is something we saw something very similar to that couple of, I should say, sessions ago, maybe a couple of weeks ago. Then we saw that even in the logarithmic functions, we saw something very similar. We saw that these questions somehow it reminds you to some, I should say, quadratic polynomials that we learned. Because we learned before that if we come to look at the cosine of the x, we have cosine of the x, this is squared here, and we have cosine of the x, which is another function here. And we learned that if we saw that, if we close our eyes and imagine that the cosine of the x is a different variable. For example, imagine that if I say cosine of the x, I call it as what? I call it as z. I recall it z. I mean, I name it something different. Then I see that the equation which I have can simply, guys, you see with the thing which I'm writing in terms of the clearness, you see the color, everything is fine. Are you Oliver, Mingji, Brian, David, Linda? Everyone sees what I'm writing?
Yes.
Awesome.
Yes, teacher.
Good. Then when we did that, we see that this expression can be simply reshaped and reconfigured into something which is going to be much easier to the thing to solve because we have seen that before. Then if I rename it by that, it becomes, instead of 3 times cosine squared of the x, I have 3 times z squared plus z minus 2 should equal to 0. Then you see that if I simply make that simple transformation, the equation which I have, if I rename the cosine dx with the z, I now have to solve simple quadratic equation, which is the easiest equation which we have learned to solve so far. It's 2, by the way. It looks like the z, but this is 2. Oh my God. My z and 2 looks like exact each other, which is bad. Anyhow, this is z. If we want to solve this equation, we have 2 methods to solve it. One of the first method is that I can just use, I should say, the simplest form. I say that to solve this equation z equals to, I have a formula which involves the determinants of this function, which we call that if the coefficient of the z is 1, we write it as -1 plus or minus square root of, again, 1 minus 4 times coefficient of the z squared times the 2 which I have. Becomes 4 times 3 times 2 becomes 24, and minus becomes minus becomes plus 24, divided by, guys, divided by what? Mingji,
Yes.
what should I write here at the denominator?
我想说那个鱼带了个
6.
6, that's right. 2 times of the coefficients of the z squared becomes 6. Then if I want to simplify that, what do I get? I get, first of all, I get minus 1 plus or minus 5, because 1 plus 24 becomes 25, the square root becomes 5, divided by 6. Then you see that at this stage, you are going to get 2 very easy roots for your z. Once we have z equals to minus 1 minus 5 divided by 6 becomes minus 1. And the other z which I get is minus 1 plus, I should say, plus 5 becomes 4. 4 divided by 6 becomes how much? 2 divided by 3. Correct, guys? Any questions so far? Everyone's okay?
Okay.
Now we have, the problem is that here now, we were able so far to figure this out, that how much is that going to be for the z? But I recall back again that z is a kind of a Zorro. I probably sure the Batman watch these kind of movies like that. Yes, Dark Knight? Maybe fall asleep. It's a kind of a Zorro. You have a mask. You have to remove the mask to see what is behind it. Then it becomes what? Then it becomes, you have to say if z is equal to minus 1, essentially you mean that the cosine of the x is equal to minus 1. Then what do? I come here. I just reconfigure this stuff. I say the first item which I got z equals to minus 1, which essentially means that it is cosine of the x which is equal to minus 1. This is cosine of the x which is equal to minus 1. And now you see that you are only, at this stage, to only solve one very simple equation of the trigonometric function. These equations are the easiest type of the functions that we need to solve. And how to do that based on the things that we learned yesterday. In order to solve them, we are just going to write, we are going to make a composition of this function with its own inverse function, that we are able to just extract the argument of the cosine of the x, which is x, from that and isolate it to solve the equation. Okay. Right, my laptop collapsed. Everyone is safe now? Everyone is safe?
Yeah.
My laptop collapsed. Okay. And what do we have now here? What do we have here is this. We have cosine inverse of the cosine of the x should equal to cosine inverse of minus 1. from this expression, if you look at this, you see that, wow, this one is going to be much easier now because I have these two functions side by side. They are from the same nature. I have cosine and I have inverse of the cosine, which it means that they are being transposed and they have been composed with its inverse, which it now enables you to remove the arguments from this. Then you're going to have only x coming outside. Then you have x equals to cosine inverse of -1. But now, based on the things that we have learned yesterday, when we talk about the inverse of the trigonometric function, it's essentially like that we are, for example, my name is Omid. If you name me and if you write my name from back to the top, which it becomes Demo. If you call me Demo, I do not respond back to you because you have to call me by my forward name. And that's like the cosine inverse. You have to always transform them into a forward function in order to see what is that argument is going to be. Then in that case, we are going to talk about like that. We say that what is the cosine of the angle what is the cosine of the angle that it becomes what? That it becomes -1. And now it's Bayburn to solve this identity, to solve this expression. Okay, guys, I'm asking you now, it becomes the easiest one. What is the angle that its cosine, it gives you -1? Aria?
Yes.
What is the angle that its cosine gives you -1? Remember the things that you learned today, even last week, and also from functions 11.
Let me think.
Huh?
Let me think.
Okay, sure.
Cosine.
Visualize the unit circle that we talked about that.
The angle, right?
Huh?
I think it's
Pi, huh? Pi? $180?
yeah.
Yeah. Then we say that, okay, now we get the good arguments for dx. Now, because the cosine of the pi becomes -1, then it's very easy to find the x. We find the x essentially. We say that now x, something that we have been looking for, it becomes what? It becomes pi, which is now, it becomes the principal root of our equation. However, you're looking for all the possible answers. Then we can just also incorporate the periodicity of the cosine functions. We said that if pi is the principal answer, we can include every answers by adding this term to that. We say plus 2 times n pi, which it means that at any pi that you are, you take another full circle on the unit circle to get back to the same spot, and you get always the cosine of that argument -1, -1, -1. Imagine that you rotate, you come back again to the same spot that you were at the pi, and that's what it does. And n can be 0, can be plus or -1, plus or -2, and goes all the way to the infinity. And it takes 100 years to finish this. Okay, and that's essentially the solution for this part. Any questions, guys? Any questions?
No question.
No questions. Thank you. Then essentially what we got here, it was the solution for the case that we solved z should be equal to -1, or essentially cosine x equals to -1. But now we have the second pair, the second part, which is z equals to 2 divided by 3. And now I'm going to solve that part. We said that the cosine of the x, which was renamed initially by, I should say, by z, and now it's going to just claim his name and identity back. It now becomes 2 divided by 3. Okay. Now, based on the things that we learned before, we said that the cosine of the x, in order to solve it, we do the exact thing that we did. We just compose that with its own inverse. That's the analytic method that we have learned. Also for the previous one, because yesterday you saw that. In order to solve a trigonometric identity, trigonometric equation, you have two distinct methods to use, and both of them, they should give you the same answer. And one of them is the analytical one, which you just, for example, write cosine inverse of the cosine of the x in order to extract the argument from the function from both sides. Or you remember that you just do the geometric interpretation. The geometric is that you just plot these two functions and see the points of the intersection, which is too many. It becomes infinite number of the intersections sometimes. But at the same time, you bear in mind that the analytical approach and the geometric approach, both of them, they should give you the same answer. And now we are at this stage. What is going to be done then? Now we see that again as before, that the cosine inverse with the cosine, both of them are from the same nature. We can apply the things that we learned from the inverse functions to extract x outside and put the rest side over there, which it becomes cosine inverse of 2 divided by 3. Okay, now, what needs to be done? Again, as I said, you have to just move back to use the forward transformation. Say that, okay, in that case, we are going to write what is the angle that its cosine it gives you this answer, that its cosine becomes 2 divided by 3. What is that angle? Now it's better to just think of this problem in a forward transformation, not the backward transformation. What is the angle that its cosine becomes 2 divided by 3? Okay, guys, what do you think? What is that angle? Of course, this is not, the answer is not those ones that we covered by, I should say, the reference angles that we were supposed to know whatever about those angles in that right triangle. That's the angle, that's the cosine of an angle, which is the reference one. Then you can just either use this one or put that cosine inverse on your calculator to find the angle. Anyone does have the calculator? Let me put that on my calculator. It becomes around 48. degrees. You can either transform that into the radians, or you can write it in terms of the degrees. Do you know how to just transform this angle to the degrees? Guys, do you remember that formula? Plus 3060 times n. Let me write this one here also, which is in degrees. Now we're going to also transform that into the radians, find the answer, which is corresponding to that radians. Okay. Now, in order to find the radians, in case some of you have forgotten how to do that, we can do this formula. We can simply, I'm just going to remind you of this because we need also to find the answers in radians to see what is that going to be. Okay. I'm just going to write a proportionality. Guys, we said that previously that any 2 pi, any 360 degrees, it's essentially 2 pi radians. And now, how about 48 degrees? How much radians is that going to be? You see, it's a simple proportionality, which becomes 48 times 2 pi divided by 360, which we can simplify that further and see, for example, 2 and 160 becomes 180, and 48, there is, I should say, 8. Let's do that now. X becomes what? For 2 pi becomes, it becomes pi. It becomes 6 pi. It's 10, which I suspect that's going to be the 3 pi divided by 5. Let me double check. It becomes 180. We have 8. We get this. We get this. That's right. Then another answer, which we can just find in terms of the thing that we derived, I'm going to write it here. Another type of the answers in radians becomes what? Becomes 3 pi divided by 5 plus 2 pi times n, which n can be any number from 0 all the way to plus or minus infinity. Okay, and that becomes the second answer we obtained. Okay, now we have 2 pairs of the answers, one in degrees that I got it from my calculator, and also this one in terms of its radians. Oh, long exercise to do that in the class. Guys, any questions?
No.
Who said no? It was Arya?
Yes.
Thanks, Arya. How about the others? Mingje, Oliver, Brian, David, Linda, Sean.
No question.
Everyone is
No
fine.
question.
Awesome. I'm so glad to hear that. Okay, now, if there is no questions, we move on to the second exercise that it's going to be even more exciting to do. Okay, let me see what time is it. Okay, the timing is perfect for this. Now, guys, now we just move on to the next exercise and we're going to solve that all together. We're just going to start for this one. We said that the cosine of 2x plus sine squared of x minus 3 times cosine of the x, it goes to equal to 1. Wow, it can't be better than that, guys. It's my favorite, it seems so far. The trigonometric equation that we are going to deal with this. Wow, wow, wow. I cannot just think that we are ending to this part. We're going to solve this. Everyone have a good view of what I have written? You see this clearly? It's cosine 2x plus sine squared of the x minus 3 times cosine of the x equal to 1. Everyone see what I have written? There's no problem? Guys, please answer when I ask a question. Hello?
Yes.
Yes. Mija, is it clear what I have written?
Yes.
Awesome. Glad to hear it. Guys, please spend 1 or 2 minutes to see how are you going to start, what is going to be your strategy, then I solve that together for you. Okay. Let's do this together. Okay, guys, for this is going to be the first type of, I should say, trigonometric equations that we are just going to work with. But we see that this trigonometric equation has a kind of a term in it which is relevant to one of the identities that we have seen before. You have learned that previously. This is actually the first equation that we're gonna just work today, which is gonna be the new chapter we are gonna work, that the trigonometric equations, which they involve an explicit trigonometric identity. We saw before that the cosine of 2x, it's equal to cosine squared of the x minus sine squared of the x. We saw this before. And now, I'm just going to incorporate this identity into the main equation which I have to see how can I simplify that further. Because you will see that without using this identity, it's almost close to impossible that we can solve this trigonometric equation. Then if you do not remember those identities that we worked before, then I have to say that you have to go back to review that, because you are going to have lots of them in the coming days. Then if I incorporate the right side of this identity into the same equation, what do I end up with? I end up with this one. I end up with the cosine squared of the x minus sine squared of the x. And now I can start to write the rest of the equation, which is plus sine squared of the x minus 3 times cosine of the x equals to 1. Everyone's great so far? Everyone's doing good? Now look at this one. If I want to continue further, look at these two terms there. Minus sine squared of the x plus sine squared of the x. And what do I get? I get this one and this one, they should vanish, because both of them, they are the same thing, but with plus and minus sign respectively. Then what's going to happen here is that I end up with a simpler equation, because 2 of the terms is gone, and it becomes cosine squared of the x minus 3 cosine of the x, and I can just take 1 from the right, take it to the left of the equal sign, replace it with minus 1, it becomes equal to 0. Now we can just stop here to take a deep breath, because we did a great job so far. We ended up with this equation, which looks much simpler to solve, because on purpose I solved something similar for you before we start the day today. Look at this equation. It's exactly like the one which we just did that on the previous example. Do you remember it, huh? And now, look at this one. I have cosine squared of the x minus 3 times cosine of the x minus 1 equals to 0. And now, look at this. Again, it reminds us of a quadratic polynomials that we can simply solve it if I, as simply as possible, make a right renaming substitution. If I call, let's say, cosine of the x, rename it to sometimes, let's say, call it u. And I put u instead of cosine of the x. What I'm going to get, guys, I'm going to put u instead of the cosine of the x. Then I'm going to have u squared minus 3u minus 1 equals to 0. And now that's simply a simple quadratic equation which we need to solve. And that's it. That's, we have to start essentially from there now in order to solve the equation. Now, guys, please, I give you, what time is it now? 5 minutes. You please continue from here. Continue from here to solve the equation. Then you see, based on the things that you learned on the previous example, then we just do that together. Please, you please continue from this part because that's the thing that we did before. I'm going to highlight this like that here for you, that you can very simply take a look. But remember, at the end, that when you just are done with this equation, remember, you just know the value for the u. You have to find the corresponding, I should say, by backward transformation to the cosine of the x. Remember, that's the essential step in this process. Okay. What was the equation? It was this equation that we're trying to solve. U squared minus 3 times u minus 1. It's a simple quadratic function, a polynomial. We know that we can just get the u like that. We say that, okay, it starts by, let's say, plus 3 plus or minus square root of b squared, which is going to be 9, minus 4 times this times this becomes plus 4 divided by 2. Which is essentially, if you can say, that u plus or minus equals to 3 plus or minus square root of 13 divided by 2. Okay, everyone is up to this point right now? Then it means that the u which you're going to get, u is going to be either 3 plus square root of 13 divided by 2, or u is going to be 3 minus square root of 13 divided by 2. And now, we notice that, guys, that u is essentially what? This is the cosine of, based on this substitution. Then we say that essentially the cosine from the first one, we say that the cosine of the x is going to be u, which is going to be what? 3 plus square root of 13 divided by 2. Then in order to solve it, we write what? In terms of its composition, we get cosine inverse of, that's the analytical solution, with the cosine of the x equals to cosine inverse of this term. Now, at this stage, I'm just going to make it simplified to see how much value do I get for 3 plus the square root of 13 divided by 2. I'm going to use my calculator to see how much do I get. Okay, now let's go to the calculator to see how much do we get. We have square root of 13. Guys, Mingzhe, do you have your calculator with the square roots?
Yes.
Yeah. Can you please make simplified square root of 13 plus 3?
Okay. It's 6.6.
Divided by 2 becomes 3.3, huh?
Divided by 2. Oh, okay. 3.3.
3.3.
Yes.
Then how come we should not get that? We get 3.3. Okay. Then there is a problem now here. Look at that. Maybe that's right. We have to continue further. Look, guys, if for this equation, that's a good thing. I'm just going to ask you just take a look. Then we're at this stage. We get the x because I have cosine of inverse of the cosine of the x. I can take the argument outside and I write instead x should be equal to the cosine inverse. Cosine inverse of 3.3, which essentially you may ask yourself, what is the cosine of the forward transformation question that we asked of the angle that its cosine equals to 3.3. Okay. Now, guys, what is the answer for this? Hello? What is the answer for that x? That the inverse cosine of it, of 3.3, is corresponds to the x. Mingzhe?
Yes.
What do you know the answer?
I don't know how to use the calculator to type the.
Even without using the calculator.
Oh, okay.
You take a look at that. You say x is equals to inverse of the cosine of 3.3. There is something horribly obtrusive and conspicuous for you. You see that? Oh, something is very strange. How about this? If I say Mingzhe and the others, what is the angle? That is cosine transformation. It gives you the value 3.3.
Uh,
234, huh?
oh, yeah.
Of course, no. I was joking. I drew some values. It wasn't there. It was a trick. There is, guys, and Mingzhe. Oh, it was so.
Yes.
Look at that. There is no angle for that.
Yeah, I also think so.
Oh, yeah. Because the cosine of any angle should be always confined between -1 and +1. And also you learn that in the inverse trigonometric, that the domain of the cosine inverse, which is going to be this argument, has to always be essentially like that, becomes the range of the cosine forward transformation, that has to be between -1 and +1, then you see that, guys, essentially, this part, there is no solution for it. For this part, there is no solution. For the case that u has to be, let's say, 3 plus square root of 13 divided by the 2, when you solve this quadratic equation, there is no roots. There is no answer. But now, we just go to the second branch, which is going to be u equals to 3 minus the square root of 13 divided by 2, which essentially it means what? The cosine of the x equals to, what was that? It was 3 minus square root of 13 divided by 2, which based on the things that you have learned, you get the cosine inverse from both sides. And you get cosine inverse of cosine x becomes cosine inverse of, and Minje, can you please in your calculator get 3 minus the square root of 13 divided by 2?
Okay. It's minus 0.3.
It becomes minus
0.3.
0.3.
Yes.
Can you give me the second digit also?
0.
Okay, 0. I think that's going to be fine enough. Then now, you see that as before, these two arguments are the same. We can get x extracted from outside, and we get this one, cosine inverse of minus 0.3. And you know that in order to answer this question, you prefer to answer it in a forward representation. And you say that, what is the cosine of the angle that its cosine should be equal to minus 0.3, 30%. Guys, what do you think of it? It has two tricks to solve this part. Guys, are you there?
Yes.
Mingje, Oliver, Sean, Linda, Brian, David, what do you think of that? What is the angle that it's cosine inverse? Mingje,
Yes.
what do you think?
Do I need to use calculator?
Yeah, sure, because you need to just get the
okay.
cosine inverse, but I recommend you work with the cosine inverse of 0.3, not minus.
Okay. It's 73 degrees.
73, let me also do that myself. 0.3. That's right, 72.5. You can just use the scientific calculators from the Desmos and type cosine inverse, and it gives you, for the plus sign, it gives you 72 degrees then. That's not the thing, but I have to just digress a little, then we just go for the break, guys. Don't worry if you feel a little bit tired. Okay, let me get my ruler, I should say, out. Let me, in order to show what do we do, because for that case, in order to solve it, we said that what is the cosine inverse of 0.3, and I didn't solve that for minus. But remember that here we had the minus, but I didn't do the minus there because I wanted to tell you something. We just worked with the 0.3 with the positive sign, and as also means your drive, it's going to get to almost 72 degrees then. But the thing is that in order to find for its minus, you have to look at the trick and the symmetry thing that we just learned about that before. What did we learn? Previously, the thing that we learned previously was this. I'm drawing a kind of a unit circle around this. I hope that you see that, although it seems too much expectation because that's pen, but these the points are the intersection of the circle with the Cartesian coordinates. You saw that if I have an angle alpha pointing with the P on the unit circle, P, this is on the unit circle. For the cosine, if that's the unit circle, you learn that simply you do what? You simply project it to the x-axis, and on that projection, whatever you read on the x-axis, for example, your x becomes the cosine. Then this is a unit circle, which it means that the radius of the circle is 1. And now you see that if you want to pick up that your cosine, also we covered that yesterday, becomes minus with the exact same thing, you learn about the symmetry of, let's say, of this, which is introduced by the circle. And you notice that you can find another angle, which this angle is going to be this, another point. I call that P prime, which when you project it down, it becomes what? It becomes minus x, because that's the left side of, I should say, the origin. And that's what we talked. But we learned that this angle, which its cosine is minus instead, it becomes what? Becomes pi minus alpha, correct? This angle from this angle, correct? You remember that? Then essentially, when we have the cosine inverse of minus 3 becomes 72, then the cosine inverse of, let's say, 0.3, if this is with the minus, becomes what? Becomes 180 minus 72. I think it becomes how much? Becomes 108 degrees then. You see? Then as a result, the x that we're looking for this part becomes 108 degrees, and I should say as a principal root. You can, as what we did before, transform that into the radiance by a simple proportionality and add 2n pi, and can get from 0 to plus minus 1, plus minus 2, and goes forward. Then that's the thing, that's how from here we use the calculator to get what is the inverse cosine of 0.3. Based on the symmetry of the unit circle, we learn that we have to transform it pi minus 7.72 degrees to get the cosine inverse of minus 0.3. Oh my God, these questions are too long to explain. And it's so hard with the camera because I hope that you didn't get lost anywhere. But guys, any questions? Any questions, guys? No?
No.
If you have no questions, guys, please take your break. Enjoy your break. It's now 10:10. Please come back by 10:25. Okay.
Okay.
See you in 10:25 then.
Okay.
Thank you. See you later. under Okay. Look at this one, guys. We have the square root of 2, which is going to be the cosine of the x times sine of 2x minus 3 times cosine of the x should go equal to 0. Okay, now you just want to just use identities to solve this trigonometric function. Okay, now, guys, take a look here. We have the square root of 2 times the cosine of the x times sine of the 2x minus 3 times cosine of the x equals to 0. Look at this term here. We have a term which is the sine of 2x. Look at this term. We have the sine of the 2x, which is multiplied to the cosine of the x, minus 3 cosine of the x equals to 0. Now, how to start solving it? I'm just going to draw your attention to the identity that we had before. We had an identity in the past, and it was this one that we said that the cosine of 2x was 2 times of sine x cosine x. Everyone remembers this identity, huh? Looking for my black marker, which it seems that it's missing now. Where did I leave my black marker? No problem. I use a different color. Oh, there it is. Okay, now look at this one now. I'm just going to substitute this expression into the term from, I should say, from the above equation. Then what do I get? The thing which I get is this, the square root of 2 becomes times the cosine of the x, and it's going to be multiplied to this term, which is essentially what? This is 2 times sine x cosine x minus 3 times cosine x equals to 0. Now, you see that I can just take 2 outside to multiply that to the square root of 2. Then I can just expand this term into 2 times of square root of 2 times cosine squared of the x times sine of the x minus 3 times cosine of the x should equal to 0. Everyone is okay so far? You see how beautiful is that going to take? You see that? Everyone is fine? Okay, now look at this. We have cosine squared of the x, and we have cosine of the x. Look at these two terms. Cosine squared of the x, and we have cosines of the x. Now, what can possibly be done Previously, in the previous examples that we had, we saw something similar exactly in the two previous examples that we solved today. We saw that the cosine squared of the x times sine x minus 3 times cosine of the x equal to 0. And what do we do now? We say that, okay, can we just rename cosine of the x with u and see what's going to happen? Can I say, for example, u squared, then I start with the sine x, which I cannot express that easily in terms of, I should say, the cosine, but in terms of the u, unless I take it as square root of 1 minus u2, u squared, then it's not going to be easy. It's not going to solve any problem. Then I see that at this stage, I cannot just use the simple substitution to call cosine x as the u and solve the equation and transform that into a kind of a simple quadratic equation, because it's not going to solve anything because of the sine x, which is attaching itself very strongly to the cosine squares of the x. And you see that if you call cosine of the x, you substitute that with the u, you get u squared times sine x minus 3u equals to 0, which you see that the sine x, it's pain in the neck. It's not gonna just be easy with that substitution. Then the thing which I'm gonna do is this. I'm gonna come here and very simply factor cosine x. I say I'm just gonna factor cosine of the x here. What do I get at the end is this. It becomes 2 times square root of 2 times cosine x times sine x minus 3 now should equal to 0. Guys, I hope that you're taking extra attention to this stuff, because these equations are getting step by step, which we do even from the next week, are going to get harder. And if you do not pay attention to this fundamental stuff, then next week you're going to be so much in trouble. But then please pay extra attention to this stuff, which we have right now. Then you see that now I have cosine x as factored out into this term. And now, look at this. Now, my equation, which it seemed initially like this, which I had the square root of 2 times cosine x sine 2x minus 3 cosine x equal to 0, by simply replacing cosine of 2x into its term, it ends with this one, that the cosine x multiplied into 2 times the square root of 2 times cosine x sine x minus 3. Now, I have to solve this equation. We had something similar yesterday. We said that yesterday that this type of equation, when you have factor out cosine x, which to the right is going to be 0, you cannot, like in, let's say, in the algebraic equation that we did in the past, you simply come to say that, okay, it's going to be, let's say, let's divide both sides by cosine of the x, then I get rid of the cosine of the x. Because if you do that, you are eliminating a huge proportion of your answers, and you are getting to somewhere which half of the solution has been done, because you purposely eliminated half of the other solution. Then always be careful. You do not remove the cosine of the x. Now, we said something very similar yesterday. We said that a times b equal to 0, then either a or b should be 0. Then I'm just going to start from the left. Then I say, okay, cosine x can be first become 0. Then what's going to happen now? I say as a first part, I assume that cosine x should become 0. By now, you know definitely what is going to be the answer, but I'm just going to write it as still full process for the analytical solution, that the inverse of the cosine x should equal to cosine inverse of the 0, then you also learned from today that you can just ask this forward question, that what is the angle that its cosine, it becomes 0. That's the other way to ask yourself that question. What is that angle, guys? That its cosine becomes 0. I'm sure that you're going to say this is going to be pi over 2, correct? Then as a result, you can come to the end and find the full solution, that you say that x has to be pi over 2 plus 2n pi, which in that case, you get the full solution, not only the principal roots, but all the roots, which it takes you to have the identity valid as the cosine of that angle is going to be pi over 2. We had it yesterday plus n pi, which causes lots of, I should say, confusion. Then I just put that as 2n pi. And, you know, it can be 0, it can be plus minus 1, or plus minus 2. Okay. Any questions, guys, on this part? It's the easiest part. Everyone is fine? Any questions, guys?
Yeah.
Nope.
No.
No question.
Everything is fine? Awesome. Thanks. Okay. Now, what else are we going to do? We are going to go to the second step. The second term is this one. 2 square root of 2 cosine x sine x minus 3 should be equal to 0. Then I'm going to take the whole expression goes to 0. It gives me another equation to solve. What it becomes? It becomes 2 times square root of 2 cosine x sine x minus 3 should go to 0. Okay. And now, I'm so far, for this identity, for this equation, I have been able to find the first complete sets of solution. For the first part, which it was the cosine x if it goes to 0, and now I'm going to find the complete sets of solution for the second pair, for the second wing of this equation, which is 2 times the square root of 2 cosine x sine x minus 3 equals to 0. What I'm going to do, I'm just going to come to this part. I say, okay, now I'm going to go to take this step. I'm going to write cosine x guys, before I just solve that for you, I want you, everyone, spend 1 minute to think how this equation needs to be solved. I'm just going to stop only 1 minute, because before I solve it, I want you to take a look to see what do you suggest, how to solve this equation. I have 2 times square root of 2 cosine x sine x minus 3 equals to 0. Guys, any suggestion, any idea? No suggestion? Oliver, Minjay, Sean, Dark Knight, David, Linda, Aria. No idea? Minjay?
I have no idea.
Okay. Guys, how about the others? Okay, I just solved it myself. Look at this. I have cosine x multiplied to the sine x. The first thing which I do, I take 3 to the other side. It becomes plus 3. But I keep 2 here. I had 2 times the square root. And now divide both sides by square root of 2. Look at this now. Look at this. You see, by a very simple trick, by a very simple manipulation, you almost finished 90% of the solution process for this equation. By this very simple trick, that you took 3 to the other side and kept 2 where it is, and you divided both sides by square root of 2. And 90% of the solution is done as easy as that. Why? Because you take a look here. You take a quick look to the left side. What is 2 cosine x sine x? It's sine of 2x. Based on the identities that we learned, and also we use that to take 2 times so far. Then as a result, what's going to happen now? Then as a result, the thing which is going to happen is going to be this. Then you have sine, instead of writing 2 cosine x sine x, you write sine 2x becomes what? I'm going to rationalize the right side by multiplying, I should say, both sides, numerator and denominator, by square root of 2. Then I get plus 3 square root of 2 divided by 2, because you know that we always find it a little bit itchy if we have the square root of a number at the denominator. Then in order to ameliorate the things, we multiply the numerator and denominator by the same square root which is at the denominator. Then becomes 3 times the square root of 2. Then at the denominator it becomes 2 then. And now look at this. Now we are at the stage that we only need to solve this equation. Guys, look at that. Mingje, Sean, Oliver, Aria, Linda, Brian, David. The equation which it seems so tricky to solve, extremely tricky to solve, by a very simple manipulation, it's ended to this, that it becomes sine 2x is this. And now you see it's much easier, huh? That's right. I'm just going to go to the next page to write continue the solution on the next page from here, the sine 2x. Any questions, guys, up to here? No questions?
No.
Okay, thanks. Now, then what did I end up with? I ended up with this one. Like I said that the sine of 2x, it's equal to what? It's equal to 3 times square root of 2 divided by 2. Quite simply, you know that when you want to solve this equation, in terms of the analytic one, geometric solution is going to be very easy. You plot sine 2x and you plot y 3 times the square root of 2 divided by 2. And the point of the intersections, which is going to be too many, they are the solutions. That's the geometric interpretation. But now, we prefer to just do the analytic solution. That's why I multiply. I take, not multiply, I take from both sides sine inverse of sine 2x equals to sine inverse of this term. So far, good, huh? I only took sine inverse from both sides. Then you will see that, guys, I have the same familiar terms, inverse of a function, which is own function, they have been composed, which it means what? Which it means that you can extract the full argument in front of the sign, which is going to be 2x. Outside, which it becomes what? Which is essentially sine inverse of this term. 3 times square root of 2 divided by 2. And now, based on the things that you have learned so far here, you ask yourself the direct question that what is the sine of an angle which becomes 3 times square root of 2 divided by 2.
No, there's no angles because sine of alpha should be smaller than 1.
That's
But-
super. That's smart.
3 times root of 2 divided by 2 is greater than 1.
That's right. Then as a result, when you got to this stage, when you want to solve this equation, you say, then I have a problem because I know that the sine has to always be within a range that it has to be between -1 and +1. But 3 times square root of 2 divided by 2 is greater than 3. Then it means that there is no solution.
No, it's smaller than
whatsoever.
3. It's smaller than 3.
That's right. There is no solution whatsoever for this equation. Then you see that when you come back to the main equations that we had, which it was 2 times the square root of 2 cosine x sine x minus 3, which we made a trick to simplify that, to look as, which one was that? To look as, which one was it? This one, sine 2x equals to 3 square root of 2 divided by 2. We saw that this pair doesn't have any solution. Then the only solution, which is a complete set of solution, is going to be this one, x equals to pi over 2 plus 2n pi, and it can be 0 plus minus 1 plus minus 2, and it goes all the way to the infinity. Yes, everyone, any questions?
Nope.
Nope, everyone is fine. What time is it now? It's almost towards the end of the class. It seems that we have nothing except that I have to just remind you of two facts. The first thing, guys, is that I'm just going to post some homeworks for you this weekend for the trigonometric equation. And the second thing is that please keep working on your project, because next week you have, Sean, you have Thursday, you have your project, huh?
Yes.
Yeah. And it's going to be Thursday for Sean. It's going to be Wednesday for Oliver, Friday for Mingji, and Tuesday for Arya. And who's going to be Wednesday? Oh, it's Oliver. Oliver. Yeah. Guys, and that's pretty much everything. And I have one simple thing to say. Sean, are you there?
Yes.
Thanks for your poster you submitted. It was great. But remember, you had to apply those codes and those analyses for the NIH datasets. The thing which you used, it was on the datasets which you will work in the class for demonstrations, for the salary, and your years of experience. Please use your codes, your analysis on the datasets on the folder of the students, which is go to the mathematical, I should say, modeling, go to the second page, click on the websites for the datasets, check the NIH datasets, and apply those techniques on that datasets for the nicotine versus vapor.
Okay.
Okay, thank you. And
problem.
any questions, guys? Then we should be pretty much done for today. If you have no questions, I wish you a very splendid and superb, superb weekend. Then I see you, yeah, and see everyone then on Tuesday. Please don't forget, if you have any questions, please email me, text me on the Schoology. Don't get too stuck. Always raise a question. We are here to help. If you have no questions, have a nice long weekend. See you guys on Tuesday morning. Thanks, everyone. Okay.
Okay, see you.
everyone.
Have a good day.
Thanks,
good
Sean.
weekend.
Have a nice day.